Given the functions f of x equals x minus 3 and g of x equals x squared, complete the table of values for f of g of x. F open circle g of x means f of g of x. The inner function is g of x equals x squared, and the outer function is f of x equals x minus 3. A table of values for a composite function uses a minimum of 3 columns. The first column holds the x values, the middle column holds the inner function output, and the final column holds the outer function output. We can use 2 function machines to complete the table of values. We'll use a pink function machine for the inner function and a green function machine for the outer function. When we plug the first x value of -3 into the inner function g of x, we get a result of 9. Plug 9 into the outer function f of x to get a result of 6. The next x value in our table is -2. Plug this into the inner function g of x to get a result of 4. Now plug 4 into the outer function f of x to get a result of 1. Repeat this procedure to fill in the rest of the table of values. In part B, we'll complete the table of values for g of f of x. G open circle f of x means g of f of x. The inner function is f of x equals x minus 3, and the outer function is g of x equals x squared. We can use 2 function machines to complete the table of values. Note that f of x is now the inner function and g of x is the outer function. When we plug the first x value of 0 into the inner function f of x, we get a result of -3. Plug -3 into the outer function g of x to get a result of 9. The next x value in our table is 1. Plug this into the inner function f of x to get a result of -2. Now plug -2 into the outer function g of x to get a result of 4. Repeat this procedure to fill in the rest of the table of values. Now we'll move on to part C. Does order matter when performing a composition? Let's bring back the tables we completed in parts A and B. Compare the rows where x equals 0. In the table from part A, f of g at 0 equals -3. In the table from part B, g of f at 0 equals 9. Since f of g at 0 does not equal g of f at 0, we can conclude that f of g of x does not equal g of f of x. Order does matter in a composition of functions. In part D, we'll derive m of x equals f of g of x. F open circle g of x means f of g of x. The inner function is g of x equals x squared, and the outer function is f of x equals x minus 3. We only need the outer function machine to perform a composition algebraically. Contrast this with the numeric calculations from parts A and B, where we required 2 function machines. Plug the inner function g of x equals x squared into the outer function f of x equals x minus 3. This gives a result of x squared minus 3. We have now composed the function m of x equals x squared minus 3. In part E, we'll derive n of x equals g of f of x. G open circle f of x means g of f of x. The inner function is f of x equals x minus 3, and the outer function is g of x equals x squared. We can find g of f of x using a function machine for the outer function. Plug the inner function, f of x equals x minus 3, into the outer function, g of x equals x squared. This gives a result of x minus 3 squared. We have now composed the function n of x equals x minus 3 squared. In part F, we'll draw m of x and n of x. Note that f of x and g of x are already provided on the graph. From part D and part E, we have the composite functions m of x equals x squared minus 3 and n of x equals x minus 3 squared. Draw the graph of m of x. Now draw the graph of n of x. These graphs match the tables from parts A and B. Note that the x value of each point comes from the first column and the y value comes from the last column.